Okay. Now, the first thing I want to cover is Nas Law because it's really the basics of geometric optics. In this question, as you can see, there are three media with different refractive indices. Let's say medium 1, medium 2, and medium 3. So the question asks us to order the refractive indices of the medium of the three media. What will we do is to apply Nas Law only conceptually and compare the angles, the refraction angles that we see in here and here, and then we will compare the indices. Okay, as you know, in Nas Law, if the angle is high, let's say theta is higher than theta 1 is higher than theta 2, let's say like this, then the refractive index will be lower to preserve this equality. So we will use this information to compare. This is not a question actually. This is only to explain the concept. So I will only go through it briefly. Here, I will first look at this interface, the interface between medium 1 and 2. As you know, we look at the angle with respect to the surface normal. So I draw the surface normal. Actually, I prepared the lines here, but it's okay. And see if this angle, let's say theta 1, is greater or smaller than theta 2. As you can see, it's smaller. It's greater. Theta 1 is greater, I mean. To see it more clearly, I can also draw the extension of this incident ray and see if it gets closer, if the ray gets closer to the normal or not. For this interface, for this refraction, I can easily see that theta 1 is greater than theta 2. Then I can say that N2 is greater than N1 because the higher angle have lower index. Okay, now secondly, I will of course look at the second interface, the interface between medium 2 and 3. For this, it may be a little bit more difficult to see if the angle gets greater or smaller. So I will draw the extension roughly. And I see that, and this is my surface normal, I see that angle actually gets greater. And the extension of this one is here. Okay, so this one would be theta 2, but I have this angle, right? Theta 3. So I can say that theta 3 is greater than theta 2. Then N2 is greater than N3. Okay, now I need to compare the first medium with the third medium. For that, I will again look at the extensions. I prepared these lines beforehand to see the extensions. Actually, I don't need this one. It would be more easier to do with pen and pencil. Also, if I'm going too fast or too slow, please inform me. And you can interrupt me if you have any question. Okay, so I draw these green and yellow lines, these lines as extensions. I will now compare the angles with respect to the same angle. I will draw one line here. This is, as you can see, this is parallel to the surface normals. So they will make the same angle with this line. So I'm looking at the angles. This is this angle, theta 3. Okay, and this is theta 1, the angle in here. Okay, so I see that theta 1 is greater than theta 3, right? Then N1 is, okay, let's say in this way, N3 is greater than N1. Okay, now wrapping all up, I can say that N2 is the greatest, then comes N3, and then comes N1. Okay, so as I said, this wasn't a question. This was only to understand the concept, because when you see the Nas law, you should know that if the light, let's say you see two different media in here, M1 and M2, and some angle occurs when there is refraction. By looking at this shape only, the angle, the refraction angle, you can compare N1 and N2, and this would help you with the problems. And also, of course, there will be problems related to Snell. Now going to the second question. These are actually your suggested problems, by the way. So I wanted to go through them for the first recitation, and it will be helpful for your quiz tomorrow. In this question, we have three media again. We have air, plastic, and glass. Light incidence from air with an incidence angle of 45 degrees and strikes the plastic surface. The plastic surface has a thickness of 3 centimeters and propagates through the plastic and then hits glass surface with thickness of 2 centimeters. And it asks for this distance, the distance between the first contact and the last contact, let's say. So to calculate this, we will first apply Nas law, of course, and then we will do some geometrical tricks, calculations actually. So here is my Nas law. You already know this, right? And 1 sine theta 1 equals to m2 sine theta. I will write it for the first interface, the first contact. I know that it may not be given every time, by the way. So you will roughly know that an air, the incident index of air is almost equal to 1. So we will take it 1 unless it's given something else. So I say that an air, which is 1, let's say 1, sine 45 degrees, as given in here, will be equal to, and plastic 1.62 times sine theta 1. Okay, let's call this theta 1. So this is my surface angle, right? This is 90 degrees. I'm looking at this angle. Okay, now now I can see that by throwing this to this side, theta 1 equals arc sine 45 over 1.62. Okay, in the quiz or in exams, you will either have better numbers, better than this, or you will be able to use your calculators. Just ask Ihorja if you will allow. So you won't need these calculations. You won't need to do these calculations from your mind, in your mind. Okay, if we do the calculation, we will find 25.88. This is degrees, by the way. In the exam, be careful. If you are doing your calculations in radians, you may be finding the wrong answer. Okay, so we have this angle now. I need to find this angle as well. I know that this is also theta 1 from the 0, you know, from the high school. I will write the Nas law again. This time I say, and plastic 1.62 times sine theta 1, this angle, 25.88 will be equal to, and glass 1.48 times sine theta 2. Okay, so I will do the same arrangement, and if I calculate, I will find theta 2 as 28.75 degrees. Okay, now the question, as I said, asks for this distance. Let's call it D, and let's say this distance is D1 and this distance is D2. So D will be equal to D1 plus D2, right? Now by doing geometrical arrangement, I will calculate D1 and D2 separately. I know this length is 3 centimeter given in the question. So D1 over 3 centimeter, D1 over 3 will give me tangent theta 1. So if I draw this on this side, to this side, I will see that D1 will be equal to 3 times tangent 25.88. If I do the calculations, I will find 0.97 centimeters. For D2, I will do the same thing. Let's carry this to here. But this time, D2 will be 2 times tangent theta 2, because this is 2 given in the question, and D2 over 2 will give me, let's write D2 over 2 will give me tangent theta 2. So D2 is equal to 2 times tangent 28.75, and it will give me 1.64. Okay, so for D, I need to sum these up, and I will find 2.61 centimeters as D. Okay. Let's go to the next question. In here we have a prism. Since these are relatively easy questions, I'm not. I won't keep asking for if you have any questions, kind of things. If you have any questions, please ask. Please interrupt. Other than that, I will just go through that quickly. Okay, so in this example, we are given a prism, an equilateral prism, which means that all angles are 60 degrees. For this question, we don't need this information, but yeah, we still have it. The refractive index is given as 1.54, and we know that an area is 1. We will always accept it as 1. And our incidence angle is 45 degrees with respect to the surface normal. So I draw the surface normals in here on both sides. And it asks for the emergence angle.
Hocam çok pardon böldüğüm için. Soracaktım da acaba soruları da paylaşacak mısınız? Çözümleriyle.
Şöyle ki size bir okay, I will share the problems. Actually, I already shared the problems. I have sent, actually Fırat Hoca sent you a YouTube link that includes the solutions of these questions. Also, these questions are the suggested problems that İhor Hoca gave you last week, I think. These questions are from Giancoli, but I can write the question numbers as well. This is chapter 32, question 48, actually problem 48.
Tamamdır. Teşekkür ederim hocam.
Rica ederim. Okay, so if you want to solve them again, you can just go to Giancoli and solve these problems, or you can just check the list of suggested problems for the first topic. Okay, so the question asks for the emergence angle, the angle of the beam, the ray that comes out from the glass to the surface, to the air. Okay, for that I will use Nas Law again, and I will do the basic thing. 1 times the refractive index of glass, 1 times sine 45 will be equal to, and glass is given as 1.4 times sine, let's say theta 1 again. This angle will be theta 1. Okay, so theta 1 will be equal to arc sine sine 45 over 1 point. Okay. And the value will be 27.33 degrees again. So now I know that this angle theta 1 is 27 over 33. Now I need to find this angle, right? Let's use violet, this angle, to find the emergence angle, this angle. But I don't have it, but I have one triangle in here, and I know that, I know this angle. I know that the surface normal will make a 90 degree, so it will be 90 degrees in here as well. So by subtracting 90 degree, this from the 90 degree, I can find this angle. It will be 62.67. And again, I know that the sum of inner angles of a triangle is 180 degrees. So I can calculate this, let's say, this blue angle, and it will be 57.33 degrees. So now again, the surface normal will make a 90 degrees. It will make 90 degrees in here as well. Then I can find this purple angle, this one, right? This one. So it will be 32.67 degrees. Now I have, if we only consider this part of the shape, now I have one incidence angle of 32.67 and one emergence angle, right? So I will apply this Nas Law again. I will say, and glass, because the light is coming from glass, it's incident from glass medium. It's 1.54 times sine. This is my incidence angle, 32.6 times 1. I will not write 1, but I know that this is air. It comes out to air. Sine, let's say theta 2. Okay, I will not do anything complicated. I will again do arc sine. This sine 32. Actually, I don't need parentheses in here. Okay, will be theta 2, right? If I do the calculations, I will find 56.23 degrees. Okay, so this is one easy question. Now, before coming to here, I have one more question. Where was it? Okay. So this is again in chapter 32, problem 55 in jungle. In this question, we have a spherical raindrop with radius r given in here. The question asks for the deflection angle. I will give the definition of deflection angle in a minute. So we can see that the light incidence from air hits the raindrop in here with a 60 degree incidence angle. It refracts and it propagates inside the raindrop, and it comes out the air and it refracts again. So all these refractions, if I draw the extension of first incidence ray, all these refractions cause a deflection, right? So this total angle change will give me the deflection. Let's denote it with phi. So the question asks for the phi, but as you can see here, I have two different refractive indices. For red wavelength and for violet wavelength. The reason is because the question wants us to know some phenomenon called dispersion. So you may heard of dispersion, but I will explain it conceptually, briefly, because the question wants us to be familiar with the concept of dispersion, not for numerical solutions, but the concept, the idea of dispersion. So if a material or a medium, let's say, is dispersive, that material focuses different wavelengths on different positions in space. You know, prisms. If you have a prism, if you strike it with white light, you know, the prism would separate the white light into its component wavelengths, and each wavelength would focus on different positions in space. The reason behind this, because each component wavelength will experience a different refractive index for this same material. I mean, we think that the same material would have the same refractive index, but for each wavelength, it will have a different wavelength. This is what dispersion is. So in this question, we need to understand that the refractive index of raindrop is different for red wavelength than the violet wavelength. So the question actually asks to find deflection of red, the difference between, let's say, deflection of red and deflection of violet. For that, I will calculate for both wavelengths separately and then find their difference. To begin with, I will again use the Nas Law, and I will not insert any numerical values until the end of the question. So I will say in here, an air, which is 1, sine 60 will be equal to, and this is an raindrop, okay? Sine, let's say this is theta 1. Okay, and I will find that sine theta 1 will be equal to sine 60 over n. Okay, so I will keep this in my pocket and I will use it in a minute. As you can see, this length is r and this length is r as well. So I can say this is also theta 1, right? Now, if I do this, if I say that this is my incident ray and this is my emergence ray, then I will apply the Snell's law again, and I will say that this time again n, because it's coming from the raindrop, sine theta 1 will be equal to 1 times, because it's going to air, 1 times sine, let's call this angle alpha, okay, sine alpha. Okay, if I substitute this value in here, I will see that sine alpha will be equal to n times this n. Now substituting the sine theta 1 as in here, sine 60 over n, and these will cancel, of course. I will see that alpha will be equal to 60 degrees. Okay. So I'm calculating this information. I will now use them. Let's get it a little bit smaller to save space. Now I have this alpha angle in here. Let's clear this a little bit. I have this alpha angle in here, but I need to calculate the deflection. What did I say at the beginning? The deflection is the difference angle, the extra angle caused by the refraction. So if I didn't have any refraction at this interface, then my ray would follow this path, right? But it didn't. It made this theta 1 angle, and it had a loss, a deflection of this much. Let's call this alpha 1. So this is my first deflection. Then again, the ray incidence from raindrop to outside, to air, and it deflected again. If it didn't refract, it would follow this path and would make this angle theta 1 with the surface normal, but it didn't. It deflected this much. Let's call this alpha 2. So my total deflection will be alpha 1 plus alpha 2. Okay, now I will try to calculate alpha 1 and alpha 2. as in here, you can see this x, right? So geometrically, this angle is equal to 60 degrees. These two angles are equal to each other. So I can say that 60 is theta 1 plus alpha 1, then alpha 1 equals to 60 degrees minus theta 1. Okay, in here, again, as you can see, there is an x in here, so this angle is theta 1. So I can say that theta 1 plus alpha 2 okay. So theta 1 in here, we were in here, theta 1 plus alpha 2 will give me alpha, the green angle, right, in here. Actually, the alpha was this, so I can say that alpha 2 will be equal to 60 minus theta 1. So if I sum this up, then phi will be equal to 60 minus theta 1 from here plus 60 minus theta 1 from here. And I will have 120 minus 2 theta 1 as deflection angle. As I said at the beginning, I didn't insert any refractive indices yet, any numerical values. I will continue with, I continued with only the end. Now it's time to insert it because we will calculate the deflection angle for these two wavelengths now. So to find phi, I will apply arc sign. Just a minute. But before that, okay, I will apply arc sign in here. Since I know that sine theta 1 is equal to sine 60 over n, to find theta 1, now I will say arc sign sine 60 over n. Okay, this will give me theta 1. Now I will substitute it in here, then phi will be 120 minus 2 times arc sign sine 60 over n. Okay, now I will insert the numbers in here. I will say, let's say phi, the delta phi, the difference of two phi's will be phi violet minus phi red. Now I will have 120 minus 2 arc sine sine 60 over n red and violet, sorry, 1.341 minus sine 60 over 1.330. Okay, so if I do all the calculations, this is actually only a 30-second calculation with the calculator. I will find 0.80 degrees. What does that mean? If I strike this raindrop with a white light, let's draw it below. If I have this raindrop, if I strike it with white light, which is polychromatic white light, the light will disperse, which means that it will separate into its components, and I will have, let's say, violet in here and red in here. Actually, this may not be true, but anyway, then I will have a 0.8 degree difference between these two refractions of the two different wavelengths. Okay. So this is the end of this question. Let's have the break now, and we will come back again at 14:30. Okay, 14:30.